In this video, we're going to look at another pattern and try to write some code to model it. This pattern doesn't look obvious at first what it's doing. If you want to think about it for a minute, I'll let you do that and pause the video. The pattern, if you can tell, it's a times 3 minus 1 pattern. So if you start at 1 and multiply that by 3 and then subtract 1, you'll get 2. If you take 2 times 3, subtract 1, you'll get 5. 5 times 3, subtract 1 is 14, etc. So that's essentially what we want to do. Multiply times 3 each time and then subtract 1. So to model this, we need to keep track of the current value, which I'm going to start at 1. And then we're going to need a loop to run as many times as we need. So it looks to me like I need to run it 18 times. So for int n equal to 1, and less equal to 18, n plus plus. And now what we're going to need to do is inside the loop body is actually apply the rule. The current value is going to be set to be the current value that we currently have tripled, but 1 taken away from it. So this will implement the algorithm. That's exactly what we want to do. It is important to talk a little bit about kind of when numbers are generated and when we should print them out if you're going to try to answer this question. So if you notice, current is 1 to start, and that's one of the answers. So I'm going to print that out, system.out.println current, before I do the calculation. And also to keep track of which number is which, I'm going to use n as a positional variable here. And then if we run this, we'll see if it seems to be doing what I want. And woo, those numbers got big pretty fast. So here it is, 1, 2, 5, 14, 41. That's modeling the pattern, it seems like. And then by the time we get to the 18th term, we will have, what is that, 6 billion? No, I can't count. There's a comma there. 0.75. So 64,570,082. So fairly large. One important thing I want to point out is if I try to add a system.out.println here at the end, I cannot print out n, because n unfortunately is local to the for loop, but I can print out current. And because current does one more calculation here, if I run it, what you'll end up with is another value here, and this would be the 19th term in the sequence. Now let's say you wanted to actually use the variable n here. And you're like, oh, I want to use n. Why can't I use n? This makes me mad. I want to do this. Well, what you could do is up here where you're declaring the variable n in the for loop signature, if you get rid of the int and actually declare the n variable before the for loop, then you'll notice that the error will go away. And now when I run it, it can accurately say that the 19th term is 193,710,245. Yeah. So once again, we've written a for loop that we can use to model a pattern to kind of find out an answer to a problem. So hope this helps.